discussing about factors affecting per capita demand, and in that, the first one, which is the size of the city, we have discussed in the last class. So today we will continue with climatic conditions. So basically, climatic condition has a direct relation with the overall per capita demand of a particular area. Now, most of you will be able to understand that, since most of you are from different parts of our country. So the overall, maximum, minimum, and average temperature are so diverse in our country in different places. So you will be able to understand, how water demand changes with respect to temperature. Let's say, at hotter and drier places, the consumption of water would be obviously more, because people would love to take more bath and more cleaning. They would run air coolers, air conditioners, and these are the reason why the consumption would be more. On the other hand, in extremely cold countries or extremely cold regions, the water consumption can be less sometimes, and it can be more sometimes due to wastage. So uh, what happens is, though in India most of the area doesn't come under permafrost situation or permafrost region, but there are few places where if you stop running the tap water, the water will immediately freeze. In order to avoid that, people keep on running the tap so that that water does not get frozen, and that is why a huge amount of water goes in waste. So this is another one issue which needs to be take into account while calculating the per capita demand and its relation with the climatic conditions. Another one issue with respect to cold region is, because of the expansion of the water to ice can create, leakage in the joints of the pipe and other appurtenances, and because of that you may have some amount of loss. So that also needs to be considered, and that also create some influence which is significant when we actually calculate the per capita demand. Next comes, type living standard of people. So this living standard basically converges to the fact that, if the people are rich, if the people are from higher income communities, they tend to use most automated instruments, and where water is required, or flow of water is required, and because of their affluent living status, the consumption of water is more in that case. Just wait 1 second. Fine. So the per capita demand of the town increases with the standard of living of the people, because more number of air conditioners would be running, more number of room heaters or room coolers, and affluent people would have big bungalows, so maintenance of lawns and use of full flush systems, latrines, and automatic home appliances such as dishwashers and so on can consume higher amount of water, and that is why the per capita demand has a direct relation with the living standard of the people in a particular region. Next comes industrial and commercial activities. So the pressure of industrial and commercial activities at a particular place increases the water consumption by large amounts. Now many industries really need huge amounts of water, fine, and that can be much more than the domestic demand which we discussed before, and increase that actually overall increases the water demand. So that is why it has it the when you calculate the per capita demand, The industry number of industries and industrial and commercial activities also needs to be assessed, in as a priority, and based on that you can actually calculate the per capita demand. Next is quality of water supply. So this is also very important, good quality and good taste, and that sort of create more consumption. So if the quality and taste of the supplied water is good, so more water will be consumed, because in that case people will not use other source such as private wells, hand pumps, etc. And similarly, certain industries such as boiler feeds, in these cases, which require standard quality of waters, will not develop their own, whereas they will use the supply water for that purpose, and that is the reason why the overall consumption or overall demand increases if the quality of water is good. Next is the pressure in the distribution system. So this most of you would be able to relate. If you see in most of the old cities and municipalities, the pressure is very less, and sometimes that is done just to minimize the demand, or just to keep the overall consumption within the limit. So how the pressure distribution, or the pressure in the distribution system is related to the per capita demand. So if the pressure in the distribution pipes is high, then what would happen is sufficient to make the water to reach to the third or fourth story building. And then what will happen is it will be directly stored in the tank. People who are living in multi-storied building, and people living in upper stories will use water freely, as compared to the case when water is available scarcely to them. Or if they have to run their own motor or other arrangements to get the water to be stored in the overhead tank. So since they are getting freely, so the consumption would be more. That is the observation which has been obtained throughout the years in the field. Next is, the losses of the water would also increase considerably if the pressure is high. If there is a leakage, if there is a wastage, then the rate of discharge through that leakage or wastage would be more, and you should be able to relate with the per capita demand. And next is the theft. Now if water is being illegally consumed by someone, and if the pressure is high, in less time he or that party would be able to consume more amount of water, and which is why that the per capita demand would also increase. Next is development of sewer facilities. So this is also one of the most important. If we have very sophisticated sewerage facilities, then the demand will also be more, because people are not bothered what to do with that wastewater. Fine. On the other hand, if the water consumption, the water consumption will be more, the city is provided with flush system, and shall be less if the old conservation system of the latrines is adopted. So these are the way you can connect with the overall per capita, connect overall per capita demand with the sewerage facilities. If we use flash system, if we use sophisticated sewerage facilities, then obviously the overall demand is going to increase. And finally comes the frequency of the supply. So this is also very important. If the water is supplied for continuously for 24 hours a day, or it may be supplied only for peak periods during the morning, evening, or maybe sometimes in the noon time when people used to take bath. Now in the second system which I have talked about is called as intermittent supplies. And in the first one, which I talked about, 24 hours continuous supply. So that is basically continuous supply. Now, this intermittent supplies may lead to, some saving in the water consumption due to losses occurring for lesser time, and a more vigilant use of water by the consumers is done. But what happens is, in many places, at least in our country, the people have a tendency to store that water since they are getting the water intermittently. And what is done is, in intermittent supply system, water is generally stored by the consumers in tanks, even larger drums and utensils for non-supply periods. And once that next supply time comes, if that water is not utilized, people would simply throw that water and then they will fill it with the fresh water. So this is the way a huge amount of water can go in wastage, and that should be considered as wastage or losses while running the intermittent supply system. On the other hand, people have general tendency to keep the taps open during non-supply hours so that efficiently they can understand when the water supply is again resumed or restored. And what happens is often water goes on flowing unattended and uninterrupted even after supply has been restored, and because of that huge amount of water goes in wastage. So that also needs to be kept in the mind, and all these activities or malpractice, you can say, has influence on the overall per capita demand. Am I audible? Hello, are you able to hear me?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Yeah, just ensure that internet connection is fine and you are able to hear me sometimes, because from my end I am unable to see whether you people are able to hear me or not, because I have shared my screen and I cannot see anything. So the next point is cost of water, and at the same time, if you people think that some points needs to be discussed again or needs to be explained again, you please stop me there and you just tell Kisar, this is the point, please explain me once again. So I will do that. And don't sit idle. If you are not able to understand or if you are not able to relate the logic which I am talking about, you should interrupt me and you should ask me again. I'd be happy to tell again or explain again. Fine. So next is the cost of water. Though this is cost of water has effect on the per capita demand, though this is not very realistic considering the economical condition or status of most of the people in our country. However, let us discuss about how cost of water is related to the overall per capita demand. So if the rate of per unit of water is high, people would have tendency to consume less quantity of water, and this may lead to the saving of huge amount of water, and that not only for the middle income group people, but for affluent and higher income group people also. There will be a huge amount of savings, since they would also have the tendency to utilize water meaningfully, as that water is coming through the metered water supply. So that is very important. And next is policy of metering and method of charging. So if we have water tax and if that is significant, and if that is imposed by the municipality or government authority, then that can create some judicious utilization of the free water supply, which usually we get in most of the cities and towns, and these days even in the villages. So if water tax is charged based on the meter reading in individual houses, and or maybe based on the fixed monthly flat rate if the income group and lifestyle of the entire community is quite uniform. So then the second method also can be adapted. However, there are certain limitations of metering policy, and sometimes it hindrances in the flow, creates the loss of the pressure, and as well as it can increase the pumping cost. So that is why and in most of the cases in India, especially in old cities where most of the water supply networks are pretty much old, there if you want to adopt this metering policy, then as since the pressure is very less in most of the consumption point, it will again hinder the flow, and then that would not be meaningful as such. And that is why these are the limitations associated with the metering policy we are mentioning over here. However, this policy making of water utilization has a significant role to play with the per capita demand. Okay, fine. So, and now we have this several other aspects which are also a big problem. So we are now going to talk about them. So factors affecting losses and waste. Since this losses and waste has significant impact on the overall, uh, per capita demand, so we are going to talk about the what are the factors which affect these losses and waste for any water supply systems. And as we have discussed before, enormous amount of water is lost due to leakage, wastage, thefts in the every water supply scheme, which you can see in your city or in your locality and in the neighborhood. Now, in order to control these laws, there is a tendency, and the government authority should take steps to minimize this loss, and it should keep within the limit. And that can be done after studying the factors which causes such kind of losses and wastes. So that is why this understanding these factors become very important. And here first one is water type joints. So this is a very important aspect of, and it has significant influence in the losses and wastages. So the joints in the main water pipes generally leak because of the bad plumbing, and that can lead to the huge wastage of water. So careful and better plumbing it becomes the most important, and the entire distribution network should be maintained periodically, and should be maintained throughout its design life in order to ensure that the water losses are can be minimized. Fine. At the same time, house connections should also be checked frequently, so that those through those connections, the nothing is getting leaked. So that part also should be ensured. Next is pressure in the distribution system. So this part, we have actually discussed surfacially while talking about influences of several factors on per capita demand. Here again, I am repeating because this distribution, the pressure in the distribution system has direct impact on the losses and waste. So high pressure, higher amount of leakage and losses, that is very obvious. And at the same time, it increases in significant amount. If the pressure is within the limit and if the pressure is high, there is a huge amount of difference which may occur. Like I can tell you here, if you if the pressure is increased by 10-meter head, then that the loss can happen up to that gets increased up to 20 to 30%. Therefore, in order to keep that leakage less, it is desirable to keep the pressure in the pipes to a minimal possible value. On the other hand, multi-story buildings should be encouraged to develop their own storage. The municipality or the government authority should not provide a pressure which would help these multi-student people to get the water stored in the rooftop tank, and that is the way we can reduce a significant amount of wastage and losses in the supply water. Next is system of supply. So we have discussed to some extent. In intermittent system of supplies, the leakage losses are reduced because water is not run for 24 hours. Rather it is being run only for 6 to 8 hours, and but there are some inherent problems associated with the intermittent system. Most of the times people would have tendency to store the water, and then once the water supply is restored back again in the next period, they are going to throw the stored water. So that is the way this the water loss may increase, even though we are adopting intermittent supplies. So that is the one which needs to be optimized, and depending upon the system of supply, there are relations with the losses and waste of the overall water supply system. Metering has another one important impact on the overall consumptions, wastage, everything. People would have tendency not to waste huge amount of water if that water is coming through metered supply. So that is why more users, they need to pay more amount of money, and that is the way you can control the losses to some extent if the metering systems are adopted. Unauthorized connection, so this is also a big problem, considering the practices in our country. If you can you can steal water through some unauthorized connections, and sometimes this may happens by offering some bribe and all. But such kind of practices should not be encouraged at all, and defaulters should be punished, because ultimately the main idea is to serve the people, and by the same time government should also be able to generate some amount of revenue, so that they can run this kind of water supply scheme or public health scheme in sustainable manner for the coming years and decades. So these are the main factors which I wanted to talk about. Now we'll be discussing about various variations which we should be considering during talking about the per capita demand. So basically, per capita demand of a town is the average consumption of water for a year. Fine. So what we do, if you can remember, so basically we calculate the overall yearly demand in terms of volume, and then we divide that by 365, and whatever we get, again we divide that by the number of people or the designed population in that particular area. So that is the way per capita demand is calculated, and this can also be, per capita demand. That is why it can also be called as the annual average daily consumption per person. Fine. So what we are doing is we are taking the annual average daily consumption. Fine. However, in practice, it can be seen that this demand doesn't remain same or uniform throughout the year, because as I mentioned, that the temperature and other mostly temperatural variations and rainfall variations are different in different season. So that is why, depending upon different season, the demand would be different. So if you take the annual average daily consumption, that would not depict the correct picture, and that is why, we should be able to understand the maximum and minimum at the same time when we are calculating the annual average daily consumption. So what is, if you see, there are wide variation in use of water in different seasons, and so that needs to be considered. Now, as far as seasonal variations are concerned, it occur due to the larger use of water in summer season, lesser use of water in the winter season, and much less in the rainy season. Fine. So these variation may also be caused by seasonal use of water in industries such as processing of cash crops at time of harvesting, etc. Now, the day-to-day variations, that is daily variations, reflect household and industrial activity. For example, I can say the water consumption is generally more on Sundays and holidays, uh, on days of dust storms, etc. The reason is very simple. During Sundays and holidays, all the citizens would be in their society, and that is why that would increase the overall demand, or that would increase the overall consumption of the water. If you have a dust storm, so it needs some amount of water to clean up all the common spaces and as well as private and public spaces. In order to do that, some amount of water is consumed. Now, on the other hand, if you realize properly, there are variations in hour-to-hour demand as well. Fine. So that is called as hourly variation. Fine. So what happens in hourly variation? If you see, the water demand at midnight would not be similar with the midday. Fine. So that is why, the consumption of the early mornings, during office hours, maybe, uh, let's say, 7 to 10 a.m., the consumption may reach to the peak, while, during the holidays, the consumption may reach to the peak during 11 to 11 hours to 13 hours. So that is the way we have to understand the seasonal variation, daily variation, and as well as the hourly variation, because based on our lifestyle, all these variations in the demand gets altered. Fine. So if you see here, minimum in winter, because less water will be used in bathing, and variation may be up to 15% of the average demand of the year. So that also needs to be, kept in the mind, that the variation can go 15% of the average, and that is why average is always not the representative. So we are talking about, daily variations. So in daily variations, these variations mostly depends on the general habits of people, climatic conditions, as I was mentioning, and the maximum daily consumption is usually taken as 180% of the average consumption. So we'll basically multiply the average consumption with 1.8 in order to obtain the daily variation. Next comes hourly variation. So we have discussed this part also, how this hourly variation is altered. Now the maximum consumption may rise up to 200% that of average daily. Fine. So what happens is, so this is, if we want to get the hourly variation, so that is basically 2 into daily variation, and if we want to express that in terms of average consumption, then it becomes 1.8 into 2, so it's basically 3.6 into average consumption, that is our hourly variations. Fine. So this is the way, all these different variations are addressed. So now we'll be talking about assessment of normal variations, and in the smaller town, more variable is there in the demand. So shorter the period of draft, greater is the departure from the mean. So that is also very important to keep in the mind. So that the maximum demands, monthly, daily, or hourly, are generally expressed as the ratios of their means. These ratios may vary considerably for different communities as well as different regions, and so that is what I mentioned several times, so that you can keep that in your mind. Now, as I mentioned, like maximum daily consumption is basically 1.8 into average daily demand, which is also denoted as small q. On the other hand, maximum hourly consumption of the maximum day, that is known as peak demand. Maximum hourly consumption of the maximum day. Just try to understand, this maximum daily demand is basically average daily demand into 1.8. Now maximum hourly consumption of the maximum day, that would be 1.5 into average hourly consumption of the maximum day. So that would come as 2.7 of annual average hourly demand. So these two are very much important to keep in mind. Many a times we will be using this multiplication factor to convert from one type of demand to another type of demand. So from average daily demand to maximum daily demand to maximum hourly consumption. So these things should be remembered clearly. Fine. So next important part which we are going to discuss over here is coincident draft. This is very very important, and if you see in most of the time during the campus placement, as well as this is very popular interview questions, I would say most of the times we tend to ignore this coincident draft part, whereas we mainly focus on other what we have discussed before. So that is why coincident draft is a very important aspect as far as community water supply system, or calculation of demand for community water supply system is concerned. So it is extremely important to keep in your mind that fire may break out at any time, and it can happen during the maximum hourly consumption of the maximum day as well. So that is basically maximum hourly draft, and when water is being consumed at that rate, during that time also you may have fire breakout. That is why for general community purposes, the total draft is not taken as the sum of maximum hourly demand and fire demand, but is taken as the sum of daily demand and fire demand, or the maximum hourly demand. Fine. Just keep that in your mind. It is not taken as the sum of maximum hourly demand and fire demand. It is taken as maximum daily demand and fire demand, or the maximum hourly demand, whichever is more, that should be considered for the design purpose. So the maximum daily demand plus fire demand for working on the total draft is known as coincident draft. Fine. The maximum daily demand plus fire demand, this total is known as coincident draft. Now, so what we are going to do is, for design we are going to either consider coincident draft or maximum hourly demand, whichever is more. Fine. So do not goof up with the coincident draft and maximum hourly demand, or fire demand. All these are different. All these are different. Now while designing, or while designing, or while calculating the overall demand for design of water supply system, we need to take the maximum of coincident draft and maximum hourly demand. Right. We'll go to the next one. So that is the design period. So design period is very important. And being a civil engineers, and at your fifth semester, all of you should be able to understand that most of the structures what we design being civil engineers has a service life. And whatever we tend to design, we sort of design that keeping in mind about the overall service life of that particular structure, and which is basically the design period. So the complete water supply project includes huge and costly constructions, such as if you start from the resources, it may consist of dams, reservoirs, treatment works, and as well as the network of distribution pipelines. So they are expensive matter. So that is why these all works cannot be replaced easily, and or it cannot be increased by its capacity whenever and wherever we want. So in future, convenient expansion is really impossible. Fine. So that is why we need to keep in our mind about the forecasting of the population, and depending upon that, within the design period, what would be the maximum uh, population, or what would be the maximum structures which we need to consider. So what will be the maximum dimensions, all those things has to be worked out in the beginning itself. So that is why we say, while designing and constructing these works, they should have sufficient capacity to meet the future demand, which is very important. So the number of years for which the designs of the water works have been done is known as design period. And mostly in waterworks, most of the components would have a design period of 22 to 30 years. And that is a significant period, we can say, because within that time, in 3 decades, you may have huge change in the population. And that is why it is important to consider the design period as a very important factor before you talk about execution of water supply project. And here I have given the table which has been taken from the Indian standard codal provisions. You can basically see them. So depending upon the different type of structures and its overall cost of construction, we have designed, we have actually recommended, or codal provision has recommended different design periods in terms of years. So you can just go through this table. We have dams, infiltration works, we have different type of pumping components, then comes the treatment units, and then we have the distribution network, and the distribution system, different appurtenances. So you can go through them, and you can have a fair bit of idea about how design period is developed. Fine. So with this, I'll stop today's class.